Alright, we're back here. Let's fire up our calculator. Okay, what I was going to show you on number 3 is that if you don't know, if you're uncertain what parameter changes are made with this equation when compared to the parent function y equals x squared, we can always just take a look at what happens on the calculator. So I'm going to type in our parent function, which is x squared. So you can see it come up on the screen there. Let's graph that. Okay, there's x squared. And for your demonstration purposes, I'll make that line bold. Okay, so so our new function is going to come in bold. And I'll type in negative 3x squared plus 7. Negative 3x squared plus 7. And then I'll hit graph, and let's see what the differences are. Okay, it looks like it's obviously reflected downward. It's shifted up, and it's more narrow. Those are the three things that you need to mention. For number 3. So number 1, it's reflected. It's concave down. I'll write CCD for concave down. Number 2, it has a vertical shift of plus 7. So vertical shift. Vertical shift of 7. I'll write positive 7 because a vertical shift could also be down. So vertical shift of positive 7. And finally, number 3, the graph is more narrow. The graph is more narrow. Very good. So we talked about its concavity, we talked about its vertical shift, its y-intercept, and we also talked about its narrowness or its width. Let's look at number 4. Which equation best describes this graph? Okay, well, let's first see if it's an x squared function. So it goes over 1, down 1, over 2. Now it should go down 4. 1, 2, 3, 4. Good. Okay, so we know that it's at least going to have an x squared in it. There's a squared relationship here. Because if we go over 1, we go down 1. If we go over 2, well, 2 squared is 4. So we see that it's open concave down, so it's going to be negative, and it's shifted up 1, so plus 1. And it's not any narrow, it's not any wider, because this relationship 1, 1, 2, 4 held, so there's no number that goes in front of here. Therefore, this is the equation. Okay, number 5. Oh, let's scroll down here. Look how fast this review is going. We're almost a quarter of the way done. What are the solutions of the function y equals negative 3x squared minus 2x plus 9? Hint, use your calculator. Okay, well, let's take a look at our calculator here. I will clear both of our things here. Now, there's a few ways you can do this. I'm going to do it the way we did it in class. So, negative 3x squared minus 2x plus 9. Okay, negative 3x squared minus 2x plus 9. Let's graph it, see what it looks like. Whoa, there it is. Now we know that the solutions are right here and right here. Those are called zeros. This, especially the TI-83, or you guys will use the 84, same thing. I prefer the 83 just because I like it old school. These are the zeros right here, here, and here. These are also called solutions. Solutions. So what we're going to do is we are going to use a function on our calculator by pressing second and then trace, which will bring us to the calc menu, and it's going to ask us to set a left bound and a right bound to pickle each one of the zeros. So, and then what'll happen is down here it'll say x equal blah 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 blah, and then it'll say y equals 0. And then we'll do the same thing for this 0 right here. That one right there. We'll set a left bound. We'll set a right bound. And same thing will happen. It'll give us x equals, etc., etc., whatever the 0 is, y equals 0. So let's go ahead and see what that looks like. Second, trace, 0, enter. Alright, so we'll set our, let's see if I can get this with the keyboard, good. So we'll set our left bound, so we'll set it somewhere down here. We'll set our right bound up here. So these two arrows you can see pickle our 0. We'll take a guess by hitting enter. Okay, there it is. Our first 0 is -2. On a test, I'd accept -2. I'd accept whatever. If you want to write the whole thing all the way out to those digits, that's fine. Looks like I just broke my stylus here. So -2 is our first 0. Let's see what our second 0 is. Second, trace, 0, enter. I told some classes this, but I had a math teacher in high school. My calculus teacher was from Lebanon, and he would say, "Zero. Let's calculate our zeros, class." So let's hit enter, left bound. We'll scroll down below our 0, hit enter. So you see that we have our two arrows. We hit enter here, and we hit enter here. Let's take a guess. And it looks like this 0 is 1.4. So our zeros for this function are -2, 0 and 1.4, 0. Those are the ordered pairs of our solutions. You can also just write x equals -2 and x equals 1.4. All right, very good, very good. If you have any questions on that calculator, see me in class, please. All right, let's move along to number 6. What are the zeros of the quadratic function below? All right, well, this is not too hard. We'll just inspect. I see a 0 there, and I see a 0 there. So it looks like one of the zeros is -1, and the other 0 is 1, 2, 3, 4, 5. +5. So those are our two zeros. You can write them like that, or you can write them in ordered pairs if you want. -1, 0, 5, 0. I like ordered pairs because these look too much like lines of symmetry to me. But doesn't matter. So there's that 0 there, -1, 0, and 5, 0 right there. Number 7, graph x squared minus 7 on the grid on the right. Let me show you. Let's use the calculator to do this. Oh, calculator, you do all our thinking. All right, x squared minus 7. Let's graph it. X squared minus 7. Okay, graph. Okay, nice graph. But now here's what some students are going to inevitably do. They're going to go, oh, well, there's our graph, so therefore our graph looks something like this. And I'm going to do this to your paper. I'm going to put a big X through it, and I'm going to write the word points, ? Meaning I need specific points. So let me show you how to avoid having many points taken off for not giving me points on the calculator. We graphed our function here. What we're going to do is we're going to press second graph to bring up our table. So let's do that. Second graph. Here is our table. So I'll scroll up a little bit, get a good sampling of negatives and positives, and what our get out of here, Java. And what our table does is it gives us several points, x, y, several ordered pairs that we can plot on the table over here. So let me move my calculator right next to our table, and let's do some graphing. So that first point, I'll start here at -2. -2, -3, down 1, 2, 3. There's our first point. -1, -6. 1, 2, 3, 4, 5, 6. Last point, 0, -7. And we know that our parabolas are symmetrical. We can graph that 3, 2. Oops, up here, 3, 2. And 3, -3, 2. And look at there, no matter how bad your parabola looks, I know. Hold on. Did I do that right? -3, 1, 2, 3, 2. -2, -3. -1, -6. Yeah. And so no matter how bad your parabola looks like, because you put points there, I know that you know what points lay on the function. And so, yeah, this is concave up. It's pointing up. And it's shifted down 7. 1, 2, 3, 4, 5, 6, 7. And it's the good old x squared relationship over 1 up 4